So at this point, I'm actually going to switch over to the exploratory data analysis. And basically, the first thing that I did was generate frequency tables. And the whole purpose of exploratory data analysis is to just get to know your data better, and so that maybe you can avoid mistakes and extra work like later on. And like we were talking about with the missing bias, it also with the missing data, it helps us to uncover bias. So we have descriptive statistics here as part of this, and one of the things that I like to do and check is whether or not the mean and the median are the same, because if they're not, maybe there's an outlier. And so the biggest area that strikes out to me is this median counts variable, so I'm going to take a closer look at that later on. And one of the optional readings talked about how, if you're using a table, you should be able to understand the trends just by, a quick glance at looking at it. And so I can certainly do that with my genotype and sex variables. But my dependent variables, this frequency table is really just not helpful because almost every single value is by itself, and all this information pretty much over here to the side is not helpful. And so the frequency table that was the most helpful and was probably the best one was the tau chi-square. But this is also kind of a bad table because, well, maybe more of a bad variable than a bad table because as you can see, all the values here, while it looks like there's a giant spread of data, there's not. All the values lie within 2 units of each other. And so we could probably come up with better ways to display that information, but it certainly helps me for diagnostics. The next thing that we did was look at histograms, and so I chose to do those basically because it's going to help me get a better understanding of how the frequencies group together and how they superimpose on a normal distribution. So my max count variable looks about as good as it gets for data that I've seen. My mean counts variable starts to look a little bit skewed, and we basically might have some outliers here. So that's one of the things we can do in EDA is start to identify outliers. And then once we get to my median counts, you can see a huge skew to the left. And that's probably due, if they got a median value of 0, the animals will probably just spent more than half of their time not running. And so that actually kind of makes sense and is probably not a great way to describe circadian rhythms. We can certainly probably figure out better ways to quantify that. And here is my variable that's basically pretending to be, or my constant that's pretending to be a variable, because you can see that everything is really, really, really close, and then we have like 2 outliers here. The last thing that I decided to do was use QQ plots to further examine, deviations from normality after IDing those outliers. And basically what I'm doing is comparing the observed value to what we'd expect based on the normal distribution. And as you can see on this next one, the detrended is actually pretty darn perfect because we want to see no pattern here as we're looking at the deviation from the normal distribution. And if there's a pattern in that, then that might be a problem. And so you can see that my mean counts variable starting to deviate a little bit more from normality. And then when we start to look at the detrended QQ plot, you can actually see that there is something here, that there just seems to be almost some kind of curve relationship. And as I move on to my final variable, median counts, the deviations from normality are probably the worst right there, which is not something that I honestly would have expected had I not done this. And you can actually see that there is some kind of linear relationship right there. And so one of the things that the optional readings talked about is these graphs kind of look boring, but one of the easiest way to screw up good data presentation is to fill the charts with visual information that doesn't convey information about the study. And so the plots in SPSS are pretty good about that, and they're pretty bare bones. And basically the implications of this is that my with these deviations from normality, if I use parametric testing, it might be underpowered. And so what I decided to do is my next step was to run non-parametric tests. And I still didn't quite reject the null. but certainly an avenue that I wouldn't have thought to try had I not done exploratory data analysis.